Hi everyone, this is Mr. Kong. This is the chemistry revision series, and today's topic is on electrolysis. It is the second part of the whole series on electrolysis. Now we'll look at a few things today. We will look at the various scenarios in which electrolysis has as a chapter. And the first kind will be on molten electrolytes with inert electrodes, followed by aqueous electrolyte and inert electrodes. Now we probably will look at reactive electrodes as well as the applications of electrolysis in the next video. Now, first of all, the various kinds of scenarios that can happen. Of course, we can have inert electrodes, and your inert electrodes include graphite as well as platinum. We can also have reactive electrodes, which are usually metals such as silver, copper, and other kinds of metals. And under inert electrodes, we have one case in which you have your molten electrolyte, which is an ionic compound that is melted to form the liquid state or the molten state. And the electrolyte can also be a dilute aqueous solution, or it can be a concentrated aqueous solution. So for aqueous solutions or aqueous electrolytes, there are two kinds, either dilute or concentrated. And in general, for reactive electrodes, we usually only deal with aqueous electrolytes. And whenever we have electrolysis, we want to look at a few things. We need to determine the products at the cathode as well as at the anode, the products at the end, as well as any changes in color in the electrolyte. Now with that, we look at the very first case, which is of a molten electrolyte using inert electrodes. Now, in all of these scenarios, the setup will be the same. And to do note, okay, that in terms of inert electrodes, they will not undergo any change at all, unlike your reactive electrodes. And for molten electrolyte, there are only two ions present. One is the cation, the other one is the anion. And remember that cations are always attracted to the cathode and they undergo reduction in the process of gaining electrons, whereas for anions, they are always attracted to the anode and they undergo this process called oxidation, where they will lose the electrons. So these two processes are always there. You have to really make sure that you know these processes well. Now let's look at a very classic example, which is your molten NaCl. And you notice here that there are only two ions present. Cation would be sodium and the anion is chloride ions. And the cation will definitely be attracted to the cathode, and Na plus will therefore be discharged as Na atoms, and eventually they form a molten form of sodium. The anion Cl minus, the chloride ions, will be discharged as chlorine gas molecules, and therefore these are the two half equations that are present in terms of the electrolysis of molten electrolyte. Now, in terms of your aqueous electrolyte, okay, it is not just the cation and the anion from the ionic compound. There are also ions from H2O, which means that your H plus and OH minus must be considered as well. And as usual, okay, the cations will always be attracted to the cathode. And now because we have more than one positive cation, we have to consider the reactivity series to decide which one get discharged. And anion, again, it is always attracted to the anode. And again, because we have more than one anion now, we need to look at the ease of discharge as well as the concentration of the anions. And these these are the three main rules that will help us determine what ions are going to be discharged and and form in an aqueous electrolyte. Now, I will stop here and I will continue the discussion of aqueous electrolyte in the next part of these videos.